Hello, my name is Nicholas Bork, and this is question one of the Quality Improvement course project. So, as you can see here, question one asks us to build a histogram in Excel and determine and create the appropriate control chart in Excel as well. So, for part A, building a histogram, the first step of action is to take all of your sample data and place it into Excel, just like I've done here, into a column. The second thing you've noticed is the bin or bucket data here. Now, there's two ways to go about this. The first way is to look at your data, find the smallest and the largest piece of data in the table, and then build buckets or bins that the histogram can sort these into based on your own intuition. Seeing as how this question did not give us any specific bin numbers, I'm going to either one, use these that I created, it's just in increments of 10, or Excel will create bins for you automatically when you go to create a histogram. So the next step is to make sure you have the data analysis tool pack installed. Now to do this, you're going to want to press File, press More, and go to Options. Here you're going to want to go to Add-ins and go to Manage Excel Add-ins, press Go. And here you will check if you have the analysis tool pack, and if you do, awesome. If not, check the box and press OK, and it will load the analysis tool pack in, and it can be found in the data section in the top right. Now, following that, we're going to open the data analysis pack. We're going to find histogram here, and we're going to press OK. Now, it's going to ask us to select some items. So for the input range, we're going to select all of our sample data, like so. And for the bin range, like I said, you can either use the bin range specified or a bin range that you come up with. But for this example, we will let Excel create the bin range itself. Now, following that, you're going to want to select labels, and you're going to want to select output range. And if you click this, you can select any open cell. After that, you're going to want to click cumulative percentage. We want to see that on the chart, and you want to see chart output as well. Now, following that, you want to press OK. Okay. And here is your histogram and the data that it pulled from. So you can see it created its own bin numbers, which work just fine for this data. As you can see, this is the distribution of data here, and you can see it's fairly normally distributed. There's a couple small outliers here and here, but overall it is a pretty even and normally distributed bell-shaped curve. Now, for the second part of the question, it asks us to draw an appropriate control chart. So, as you may have seen here, I inputted the sample data already, again, just to save time on this video. And for the control chart, what we're going to decide to use here is X bar chart and an R bar chart. And why we're doing that is because this is continuous data. So we want to use this because it's not an attribute. So we don't need to use an attribute chart like a N chart or an NP chart or a C chart or a U chart. We're giving continuous data, so we're going to look at an X bar chart and an R bar chart. Now, again, the first step is to insert all your data as shown in the problem down here. So I took this and I implemented it straight into Excel. Next, you're going to calculate the sums, the average, and the range for each sample. And you can see within each sample time or sample location, whatever it is, there's 5 simple samples in itself. So to do the sum, we're going to do equal sum and add all of these in the single sample together. And now we can drag this down to get the averages for each sample, or sorry, the sums for each sample. Now a grand average, which is an X double bar, is not needed for the sum. Next, we're going to do our average, and again, to do this, you're going to press equals average, and we're going to take all the data within each sample and obtain the average. And here you do want the grand average, which is again X double bar. So we're going to do equals average again. We're going to select all the averages we just took and take the average of that. Following that, we're going to find the range. And you can use formulas to do the minimum of the cells minus the maximum of the cells. However, I find it easiest to just look at your data, pick the largest number. So for instance, on the first one, you have 64.3. And then subtract the lowest piece of data, which is 28.5, and that's your range. And we can do that for each sample. So for the second one, 75.2 is the largest, and 28.6 is the smallest. Again, for number 3, 62.2 is the largest, and the smallest is 29.5. Again, for number 4, the largest is 62.4, and the smallest is 32.1. Okay, and then finally for number 5, you have 85.6. It's one of our outliers, minus 18.9, our second outlier. So once you've got all your ranges, we're going to do a grand average of those items. Now, these become your X bar and your R bar. Okay? So, now we're going to calculate the control limits for the X bar and the R chart. Okay, so the control limit for the X chart is your X bar, and the control limit for your R chart is your R bar. Now your upper control limit is calculated as X double bar, which again is your 48.31. So this, and then plus this A2 value. Now, side note, this A2, D3, and D4 value were taken from a chart provided in class, and these are constant values that apply to the amount of samples you have within your chart. So we had 5 samples, so the value for A2 here is 0.483. And then we're going to multiply that by our R bar value. And we're just going to take the decimal places down some here. I'm just going to double check this data here. Sorry. Okay. All right, continuing on. Your lower control limit is the same value. However, instead of a plus, it is a minus. And this is your control line at the 3 sigma level. Now, to get your upper 1 sigma and your lower 1 sigma, the formula is as follows: x double bar plus that A2 value down here, 0.483, times your R bar value and divided by 3. And again, I'm just going to take down some decimal points here to clean this up. And your lower 1 sigma is the same deal, but again, instead of plus, it is minus. Now to get your upper 2 sigma, the formula is your x bar plus 2 times, again, that A2 value times your R bar value, and then divided by 3. And again, just going to clean up this data, and same thing here. I'm going to pull this down, make sure all your data is correct, and then switch this out for a minus to get that lower 2 sigma value. Okay, so the data needed for our X bar chart is completed. I'm going to plug it into this small chart over here. So our upper control limit is 68.80. Our lower control limit is 27.82. Our control limit is 48.31. Our upper 1 sigma is 55.14. Lower 1 sigma, 41.48. Upper 2 sigma is 61.97. And our lower 2 sigma is 34.65. Now we have 5 spaces in this chart because there are 5 samples. So we're going to do this. I'm going to drag it all down. And now we're going to build our X bar chart. Now to do this, we're going to select all of our averages. We're going to hold Control. We're going to select all of our control limit items. We're going to go to Insert. we're going to go to 2D line, and we're going to select the first option. Now I had this issue earlier where my data came out like this. So to change this, we're going to open the filters, we're going to select the data, and we're going to switch row and column. Press OK. And here we'll change it to X bar chart. Now, as you can see, we have our central limit and our 3 sigmas up and down. Denoting what the limits are. So if we take a look at this, it appears that no point okay, well, that's cluttered. Anyways, no point goes below 1 sigma except for this. Below or above 1 sigma, it stays relatively close to the control line. So it seems that the process is in control, but let's move along and work on our R chart just to be sure that said process is actually in control. So again, for the R chart, we're going to do the same process. Our control, or our center line, control line, is 42.42, our R bar value. Now the upper control limit is calculated as this D4 value, which again I pulled from the sheet provided in class, and it's multiplied by the R bar value. And we're just going to clean up this data. And for the lower control limit, it is this D3 value, again found from the sheet provided on Canvas, multiplied by the R value. So this D3 value times the R bar value. Now for upper 1 sigma, it's going to be your R bar plus that D4 value times the R bar value minus the R bar value divided by 3. And the lower 1 sigma is the same. Make sure your data is correct. And then you want to switch this plus to a minus. There we go. Now your upper 2 sigma is very similar. It's going to be your R bar. And it's going to be plus, again, 2 times, again, that D4 value times the R bar minus the R bar, and that's all divided by 3. Again, we're going to drag this down, correct our data, and switch this to a minus. Now that we have all of our data, we can throw it into our R chart control limit chart here. So 42.42. Our upper control limit was 85.01. Our lower control limit is 0. Our upper 1 sigma is 56.62. Lower 1 sigma is 28.22. And so on and so forth. And just like last time, I'm going to highlight all these, drag them down to fill in the table. We're going to select all of our averages, hold Control, and select this entire chart. We're then going to press Insert, go to 2D line, and select the first one here. And as you can see, we will name this our chart. As you can see, if we bring both of them next to each other, with both the X chart, X bar chart, and the R chart, the items seem to be in control as they stay near the center line. They do not vary very much. They do not go up or below. They're not more than 4 points up or above 1 sigma. So again, interpreting these, it seems that the process is fairly in control despite a small number of outliers in the data. And that was question 1 for the Quality Improvement course project. Thank you.